Hello, Serdar Yegulalp here for InfoWorld at IDG. In this episode of Smart Python, we're going to look at the basics of the Pillow library, a commonly used library for image processing in Python. A Pillow is derived from an earlier library named PIL, sometimes pronounced PIL, which is short for the Python Image Library. But you don't need to know anything about PIL to use Pillow. In the examples I'm going to show, we'll be importing Pillow as PIL, and Pillow works that way to be backwards compatible with existing scripts that use PIL. But again, you don't need to know anything about the predecessor. With Pillow, you can work with existing images in common formats, or you can create entirely new images programmatically. For the sake of this demo, I'm going to focus on manipulating existing images, since that's a more common scenario and a little bit more straightforward. But in a future installment, I'll show some examples of how to create new images entirely from scratch. So let's start with a simple task. We're going to load an existing image and we're going to display it. One nice thing about Pillow is that we don't have to know any of the technical details about any image format it supports. Encoding and decoding are all handled by Pillow behind the scenes. To work with an image, we use the image class, and we can use image.open to read a file from disk. And again, common formats like JPEG are supported natively. And we store the results in a Python object as a bitmap. The object's properties, like format and size, give us useful information about it. Mode tells us what the color information in the file is. In this case, it's RGB. The show method invokes whatever program is registered with the system as the default image handler to display the image. On this computer, that program is IrfanView. The results may vary on your machine. I should note that the way that it does this is by taking the raw image data in the object, writing it out to a temporary file in the lossless PNG format, and then invoking the image viewer to show that. This will become important a little bit later. For now, though, let's try and do something actually useful with this image. Let's take this image, let's load it into memory, and let's resize it to make it more manageable. To do this, we use the thumbnail method, which resizes an image in place. And the way I'm invoking it here, it's set to be 800 pixels on its longest side. And the results will then be resaved back out to disk as a JPEG. The original image we're working with, by the way, is huge. It's several thousand pixels on the side. That's nice if we're working with print, but it's really unwieldy if we want to put this in a web page. Once it's resized and saved, though, you can see from the image properties here that it is a good deal smaller in both its image and file size. By the way, I should note that for this script we're using the os.startFile method to show the image. What this does is it takes in a file name and then uses the operating system's default handler for that file extension. So this way we can actually display the file that we wrote out to disk. We're not just displaying a temporary copy of the in-memory data that we created, because that may not be an accurate reflection of the file that we wrote out. Another common operation that we can perform is compositing images. In this example, I'm going to open two images. One of them is the droplets image that we were working on before, and another is a color gradient background. And then we resize both of them, make one smaller than the other, and use the paste function to add the smaller one to the larger one at specific coordinates. This math here, by the way, is how we're centering one image inside the other. Pillow does not have a native way to do this, but we can do it ourselves without too much work. We just need to know the width and height of each image, and we can get that from its properties. Also, you'll notice that when we save out the composite file to a JPEG, we're passing a whole lot more arguments to the save function. The JPEG output module in Pillow, in fact, all of the image output modules in Pillow, have knobs that we can tweak to control the image quality. In the case of JPEG, we can control whether or not we want a progressively rendered image, which is useful for slow downloading, or whether we want to perform extra optimizations on the saved image data at the cost of the save process taking a little longer. So when we run this, we start off with our gradient, which is gigantic, and then we have our final composite, downsized and saved as a JPEG. Pillow also lets you perform detailed operations on the components of an image, namely its color channels. In this example here, I'm going to load in that droplets image, and I'm going to split it into its red, green, and blue color components with the split function. We can then remerge the color channels, and we're going to swap red for green, green for blue, and blue for red. First time we run this, first thing we're going to see is the original image. Then we're going to see the green color channel, which is black and white, because the color channel itself has no color information. It's just all the data that goes into the green channel of the image. So there's no way to present it except as a black and white image. And then finally we have the merged result, which looks a little like we've been messing with the color controls on our TV. One more thing Pillow can do is add text to an image. To do this, we use two more modules from Pillow, the Image Font module and the Image Draw module. Image Draw sets up interfaces for a given image for us to draw to. And Image Font lets us set up a font at a given size to be used in the drawing process. So with this example, we're going to draw two pieces of text, one up in the corner of the image and a second one centered. And again, to center the text, we need to get information about its size, and we can do that with the getSize method for the selected font and the text that we're using. Once we do that, we can calculate its position and draw it there. You'll also notice, when we run this, that our text options are not just limited to size, but also to color, the inner color, the stroke width, and so on and so forth. This is not a full substitute for, say, Photoshop, but it is a convenient way to add text to an image programmatically. Now, everything that I've shown here barely scratches the surface. Many other things are possible with Pillow. I mentioned before generating entire images programmatically, and I'll be taking a deeper dive into that in a future video. But what we have here should give you an idea of why Pillow is immediately useful. It gives you a high-level programmatic way to work with images in Python, and lets you perform common, complex operations on them without having to know anything about the details of the image formats themselves. So that's it for this video. If you like it, please leave a comment below. Don't forget to subscribe to the IDG Tech Talk channel on YouTube. And for more Smart Python and more Dev with Serdar, be sure to join me on Facebook, YouTube, and Infoworld.com.